Complete the square and factor the result. X to the fourth plus 8x squared. This one's a little bit different because we have higher powers of x. We have x to the fourth and we have x squared. But x to the fourth is still a perfect square. It's x squared squared. It's this x squared but squared. And so even though this looks a little bit different from what we've seen earlier, we can still use the same procedures to complete the square. Let's give it a try. If we look at the coefficient on the x squared, we have an 8. If we divide that by 2, that gives us 4. And if we square it, we get 16. So we've got x to the fourth plus 8x squared plus 16. Now, if we want to factor this, we have to start with x squared, because x squared is the thing that we square to get x to the fourth. Then we have plus, well, when we took 8 and divided it by 2, we got 4. So x squared plus 4, quantity squared. Now, this one is a little bit different from the rest, so if we want to, we can check it, and we can check it by multiplying x squared plus 4 squared is x squared plus 4 times x squared plus 4. And we can FOIL this out. If we multiply the first terms, x squared times x squared is x to the fourth. If we multiply the outer terms, x squared times 4 is 4x squared. If we multiply the inner terms, we also get 4x squared. And if we multiply the last terms, 4 times 4 is 16. And then if we combine the like terms, we end up with x to the fourth plus 8x squared plus 16, which is what we had after we completed the square. So we know that that is the correct factorization, and we know that that's a perfect square. And so our answer is going to be that adding 16 completes the square. And when we factor it, we end up with x squared plus 4, quantity squared. And I just want to point something out. This technique that we use of taking something that we've already done and applying it to a problem that's slightly different, and then in the end checking to make sure that everything works out, this is a more simple example of what mathematicians end up doing. Usually if there's some sort of an unsolved problem or a situation that someone's never dealt with, the procedure is to take something that you already know and attempt to apply it to the new situation and check to make sure that if it works. And if it does work, then you know it's good. And if it doesn't work, then you try and manipulate it or change it a little bit to make sure that it does work. So getting practice with this sort of thinking is one way that students can build up their logical thinking skills and their creativity to look at more complicated situations and become better problem solvers.